Hello everyone, welcome to the channel Physics Fun. So in this video, we are going to discuss a very important concept. And then based on that concept, we are going to solve two questions. One is laws of motion, objective question 38. Another is kinematics, build up your understanding, question 38. This is based on spacecraft taking a turn. This is based on car taking a turn. And this is a very important concept. I'm surprised why JEE Advanced have not asked this question or any question based on this concept till now. And then once you go through the concept, you will realize yourself that this concept is so very important for JEE Advanced that in this can any question, these two questions or any other question, similar question based on this concept can come in JEE Advanced 2022, right? So let us carefully understand this concept and then we will apply the same concept in these two problems so that your understanding is better and you get confidence. So let us move to the concept here. The concept is now the concept says that to change in velocity vector, suppose you are moving in a car like this in this direction, and you want to take a turn so that your velocity vector becomes this way. Initial velocity and final velocity, initial speed and final speed is same, right? And acceleration is constant. Suppose when you're taking a turn, the maximum acceleration is the maximum friction force mu mg divided by m, right? So mu g. So that is the maximum acceleration, right? So you can always move such that you get maximum acceleration, which is constant. Change in velocity vector should always point towards the acceleration vector, right? So this we will understand very carefully. Now suppose this is the initial velocity vector. See this is initial velocity vector. This is final velocity vector. Here magnitude was v naught. Here also it is v naught. Now if you use vectors, then change in velocity vector will be what? V final, which is this, minus V initial, which is this, right? V initial is in this direction. So minus V initial is in this direction. So this will give us the change in velocity vector in that direction. So suppose this is V naught, this is V naught, this will become V naught root 2, right? Now, if you want to attain this, achieve this in minimum time, then your acceleration vector should always point in the direction of change in velocity vector, right? This makes sense also because the entire, if you want to do this in minimum time, then entire acceleration vector should be utilized in changing the velocity vector, right? A is equal to dv by dt. If suppose acceleration is pointing in this direction, then only a component of that will be utilized in achieving the velocity vector, right? You will not get the minimum time, fine. And then second point here is if acceleration is constant throughout the motion, then resulting path is parabolic. This all of you know. Here there are two examples. One is that if suppose the particle is thrown with a velocity v naught and it is under gravity, it is in vacuum, no air drag, then path is parabola. And if there is an air drag, but due to air drag, there is a constant acceleration or retardation in x direction other than gravity, then also path is parabolic, right? Because here if initial velocity vector is in this direction, then if acceleration vector is in this direction and there is one angle which is non-zero. If angle is zero, then path becomes a straight line, right? This we understand. And this acceleration remains constant, then path will be parabola always. Fine. So let us apply this concept now in this question. This is laws of motion, question number 38. Very, very important question. This question, exactly same question can come in JEE Advanced 2022. So let us see. So there's a car, it is moving with 108 kilometer per hour. So we can convert this in meter per second. So that will come out to be 30 meter per second. 5 by 18 you can multiply on a large uniform platform. So this is the platform perpendicularly towards a wall. You can see it is moving perpendicularly to avoid collision. So if it moves continuous straight, it will collide with the wall, right? We can see the driver takes a turn and finally runs the car parallel to the wall with the same speed. So this is going to happen. So finally car is going to move this way with the same speed, right? V naught here and V naught here, correct? And then coefficient of friction between the tire is 0.6. So we know that maximum acceleration which driver can achieve is mu mg divided by m, which is mu g, that is 6 meter per second square, right? And all the load of the car is concentrated on the front axle, so that you can consider that as a block, right? And then if the turning process is the fastest one, then check validity of following statements, right? Same concept. Okay, so same thing now I have explained again here. Initial velocity vector, see this one. Final velocity vector is this. Change in velocity vector, see this diagram, v final minus v initial minus, right? So this direction is changed. So this is delta v, right? Now, if you want to achieve this in a minimum time, acceleration vector, this one, right, should also point in that same direction. Then only all the time, at every instant of time, acceleration vector should point in the direction of change in velocity. Then only process will be optimized and you will be able to achieve this change in velocity in minimum time. So this is acceleration vector, right? This makes this path parabolic. So A option is car follows a circular path. This is wrong. So we'll cross this here. And the car follows a parabolic path during the turn. This is right. So then another C option is minimum radius of curvature of the path. So when car is taking a turn, that time what is the minimum radius of curvature? Since it is not a circular path, so radius of curvature is not constant. We need to find out what is minimum radius of curvature. Let us see how to be find. So radius of curvature formula is R, which is V square divided by A perpendicular. A perpendicular is component of acceleration perpendicular to the velocity. See this diagram? In this diagram, suppose car is moving along this, velocity is tangent, acceleration is this way. Then radius of curvature is V square divided by component of acceleration perpendicular to the velocity. So this component, this is A sine theta, right? This you can relate with centripetal acceleration. This is centripetal acceleration V square by R, right? So same thing. Now to find out the minimum radius of curvature, this will be minimum if this is minimum, right? And the component along the perpendicular is maximum. Fine, do you understand? Now here, initially, this is the diagram at t equal to 0. See this diagram? Velocity was like this. Acceleration vector is always like this. Then only we can achieve this in a minimum time. And then now I have taken these two components. See here, this component and this component for velocity. What will happen now? Over the time, this component will become 0 because there is a retardation and this is perpendicular. So acceleration is perpendicular to this component remains as it is. That time velocity vector will be minimum, right? So now at some t equal to t naught, this velocity vector becomes 0 because there is a retardation. This remains as it is, which is v naught by root 2. And now acceleration and velocity are perpendicular, right? So at this instant, you get minimum radius of curvature. We can apply this formula now. R is equal to, here velocity is v naught square, v naught by root 2 square. Acceleration we have found, that was 6. So v naught is 30, you can substitute and find out 75 meters. That makes this option also correct. D option, initial distance of the wall must be greater than 75 root 2. So now when it is taking a turn, this distance we need to find out. This would be D option. We have to check whether D should be greater than 75 by root 2. If it is less than 75 by root 2, then car will hit the wall. Let us see. So D part is calculating minimum distance. Initial distance is D. Now first we'll find out time, right? So initially it is going this way. Now it is going this way. I've assigned this as X direction. This is Y direction. If you see now, initial and final, velocity in X direction becomes 0, right? It has taken a turn. It starts moving in Y direction. So when velocity in X direction becomes 0, I can apply V equal to U plus AT in X direction and find out time. So V equal to U plus AT in X direction, 0, 30, and then initial velocity is 30. Acceleration is 6 by root 2, T. So T we get as 5 root 2. Then after that, this distance we can find out. By applying, this is X displacement. So we can apply S is equal to UT plus half AT square in X direction. So D is equal to V naught is 30, time is 5 root 2, half, acceleration is 6 by root 2, actually retardation 5 root 2 whole square. So if you solve this, you get 75 root 2, right? So D option is also correct. So I will mark D option also here. Fine. So this question is solved. Final answer is B, C, D. Now let us see one more question, which is based on exactly same concept. This is from Kinematics, same question number 38, but this is from Build Up Your Understanding. So question is that there's a spacecraft is moving in space where all the external forces can be neglected. Any change in speed and direction of motion can be accomplished by rockets installed in it At an instant when it is moving with a speed 100, decided to take a turn 90° with an acceleration of constant modulus, right? So let us mark here the important point. So this is constant modulus, and then sorry, then move in new direction with the same speed v, right? So you see that it is the same speed, same question, same condition. The rocket installed can provide a maximum acceleration of 5√2. So you see that it is the same concept. Minimum time spent in and the shape of the fall path follows during the turn. So you know that shape will be parabolic. Again, same here. Sorry, same direction, same diagram. V initial, V final. I've taken this X and Y. V final minus V initial is the velocity vector. This one, acceleration should be in this direction. And to find out time, acceleration is given 5√2, velocity is 100. To find out time, we can just do what? We can equate initially aircraft was moving this way. You can see here finally in this way. Then when it has completely turned, the next component of velocity becomes 0. So V is equal to U plus 80 in X direction. V is 0, U is 100, right? That is what is given. See the value. And minus 5. Why 5? Because acceleration is 5√2. It is in this direction. Its X component is. So this, let me write here, Ax is equal to 5√2 cos 45. So it is 5 meter per second square. This is Ax. This is basically retardation. So minus 5 into t. So you get t equal to 20 seconds. Right? So you can see exactly same concept. There are two questions, all, and then most of the questions in Pathfinder book is the Olympiad question, right? So it's highly probable that based on this concept, you get a question in this year JEE Advanced 2022. If you have any doubt, you can watch the video again, or you can just write your doubt in comment section. I will try to clear your doubt. Fine. So if you have liked this video, then please share this video with your friends, subscribe to my channel, right? That will motivate me to upload more such videos, right? That's it. Thank you very much. If you're watching till this time, thanks a lot. And then we will meet again in next interesting video. Thank you very much.